Right, so our last speaker for this session is Chris Phillips. And Chris is a senior scientist with the Manaaki Whenua. Chris has published over 70 scientific papers and book chapters and authored many reports for a range of clients. And he's a past president and an honorary member of New Zealand Association of Resource Management, which is us. His topic is erosion and sediment control, how to assess effectiveness. Welcome, Chris.
Kia ora tātou, thanks Peter. I might just drop this down a bit since I'm not quite as tall as Tom. The question posed on the title of this talk seems simple and easy to answer. And it may look like we have our head in the sand, but assessing the effectiveness and performance of erosion and sediment control is neither simple nor easy. So today I'm just going to share some of what we've been doing to address this particular question. So what we'll cover is why we're doing this, what we've done, where we might be headed, and then I'll wrap up having left you with some insights into the topic. I think you all know about the why. Sediment is one of the key contaminants that affects water quality right across the Motu. And clearly, if we can reduce erosion and limit the amount of sediment from entering waterways, that's going to be a good thing. So this work is one of 4 research areas within the Smarter Targeting of Erosion Control, or STEC research program, and there are a bunch of posters out there if you haven't already seen them. So along with other elements of the program, it's all aimed at providing new knowledge and tools to help answer questions around what do I do, where do I do it, can it get us to where we need to be, how long will it take to be effective, and where will give the best bang for the buck in terms of reducing erosion and managing sediment delivery to streams. And unlike Tom, we're only interested in sediment, not the other contaminants. So a couple of years ago, we undertook a significant review of what we knew about ESC, or erosion and sediment control, effectiveness and performance in New Zealand. And we then benchmarked that report with some international collaborators to get a feel for how New Zealand was placed in terms of what was being done here. Now, at this point, it's probably useful to define what we mean by effectiveness and performance. In this work, we define ESC effectiveness as the extent to which the soil conservation or ESC practice achieves the desired outcome. In other words, did it work? But we really don't know, in a quantitative sense, how well it worked. Performance, on the other hand, is the actual measure of sediment reduction the device or intervention results in, and is usually expressed as a percentage relative to a control. However, in common usage, those two terms are often used interchangeably, which is one of the reasons why effectiveness and performance are actually poorly understood. So not surprisingly, while there is some information on the performance of common ESC practices, the data bucket is basically not overflowing and is largely full of generalities rather than specific values for different environments, such as for different soil types and under different rainfall regimes and so on. So typical performance values for common treatments are highly variable, as you might expect, but many of those interventions only ever reduce sediment loss or sediment delivery to waterways by half. The type of erosion process the treatment is trying to mitigate is also really important, as the same treatment applied to a different process may deliver different performance values. And for those ESC practices that involve trees, shrubs and vegetation, it can take anything up to 10 years before they are deemed effective. Now, both of the reports which I highlighted earlier have highlighted a number of research gaps and recommendations, some of which are listed here, and without going into the detail of those today, I refer you back to those reports. But I guess what all this means in practice is that to improve how our erosion and sediment control mitigation measures are used to reduce erosion or capture sediment, we need to pay significantly more attention to both understanding the future performance of individual and multiple measures and to assessing those against the appropriate targets. We also need to pay more attention on acquiring economic data, because in many cases it may be that the cost of intervening outweighs the maximum potential benefit that could be gained, even if those implemented measures were all performing at their most efficient. In other words, hitting the problem with everything we've got in the toolbox may not be enough to reach the acceptable or regulatory water quality target. So just turning now to some more recent work. So over the last 12 months, with the help from our stakeholders, we co-developed an evaluation framework that could be used to assess the performance and effectiveness of erosion and sediment control mitigation measures. 20 participants from a range of agencies contributed and provided input via a number of virtual workshops, and I thank those who participated, many of whom are actually in this audience today. Some key needs and questions from the early workshops are listed on the slide, and we won't go into those at the moment. But we didn't really start from scratch, but we looked at similar frameworks and asked participants what they liked, what they didn't like about those frameworks, and ultimately the two versions of the framework we developed built on aspects or parts of those other approaches. And before we get too far, here are some kind of key things the participants wanted in a framework. It needed to be simple, it needed to capture the concept, it was easy to understand, and it was familiar to them. It was potentially expandable into a tool, it could address multiple scales, it included or gave some reference to Maori and as part of the framework, and it referenced common tools and methods that were currently available. And this led us to the design of version 1, and don't all gasp in horror. And now while this actually captured most of what participants wanted, as they had expressed in those earlier workshops, it was, as you can see, way too complex and really overwhelmed us in terms of how the hell do we actually use this. Particularly so when it was revealed that the framework was not just that little circular bit, but a whole bunch of tables that were sitting to support that sort of circular diagram and the 5 phases in the central part of the framework. And so what this led was to a major rethink of what we were trying to do, and the realisation that that version had moved from a framework into a tool, and that the scope of what we'd set out to do hadn't just crept, it had performed a major leap into territory we hadn't anticipated. So it was back to the drawing board, and this is where we've landed in terms of version 2, a 3-part framework that acts as a reminder for what needs to be considered and a process to follow for assessing erosion and sediment control effectiveness. So the left-hand side is a cut-down version of a generic project planning framework, which I'm sure you're all familiar with. The top right-hand part focuses on what erosion process is being mitigated and the scale at which its control is considered. But in practice, many, if not in most situations, there will be a combination of erosion processes, and the relative importance of each and/or the magnitude of their contribution to sediment delivery to streams will be the main determinant for actually selecting the control methods. Similarly, the scale in which ESC is applied is important, because the actual control measure is implemented in a specific locality, but its actual assessment may be undertaken at different scales and away from where it was actually implemented. And lastly, in terms of the assessment, the lower right part of the framework considers how effectiveness and performance are actually assessed, either through measurement, monitoring, modelling, or through what we call experience. So where to next? Well, we're now linking with economic work in the program, which is focused on understanding benefit and cost of erosion control, as well as linking with the development of an event-based model to complement our existing SEDNet NZ model. As part of our work, we've also established trials, which Tom's just mentioned, to provide future information to support aspects of silvopastoralism. And lastly, I just want to make another plug for the posters that relate to the STEC program, and you should have a look at those during the poster session. So finally, to wrap up, I hope you now know a little more about what's being done to assess erosion and sediment control effectiveness and performance in New Zealand. As I said at the start of this talk, our work is really focused on the contention that smarter targeting of erosion control will lead to better land and water outcomes. And other talks like Raphael's and indeed Tom's have clearly demonstrated that this is indeed the case. While the program has 1 year to go, I believe our research advances and our new knowledge is starting to provide clarity, and please excuse that as a pun, is suggesting that with the right data at the right scale, targeted cost-effective erosion control can yield significant improvements in reduced erosion and sediment delivery to waterways, and as a result contribute to improved water quality and to Te Mana o Te Wai. So thanks for listening.